Okay, I think we can start now. And I think before I introduce our speaker for the day, I'm just going to briefly give you a bit of context about our two trusts and more importantly about Mr. Narayan Dutt, whose memorial lecture it is. It's the 7th memorial lecture of Mr. Narayan Dutt. Now, he was a journalist who joined Gurukul Kandi at a very young age. And after he finished his Gurukul, he obtained the Vidyalankar degree and he joined the Hindi of the screen. And that was his first job in journalism, but wasn't his last job. He then joined Navneet and then joined PTI, where he became Hindi features editor. And he had a very deep grounding for an atheist. He had a very deep grounding in the Vedas and the Upanishads and the epics. And he had a very strong sense of wanting science to be popularized in Hindi and translated a number of interesting scientific articles into Hindi and tried his best to get the topmost scientists to write as much as he could. And then little about Devagitam Trust. It's dedicated to preserving and propagating the work and interests of H. Yoga Narasimham and H.Y. Saraswati, who's both my maternal grandparents and Krishna's maternal grandparents. And the focus of the trust is on music, literature, and academics. And our maternal uncle, H.Y. Mukunda, is the current president. Abhignana, which is our collaborating trust, it publishes books, organizes events, and has a lot of activities, as you can see, and is led by Mr. Surya Prakash Pandit, who has worked in the areas of art and philosophy and journalism over 25 years. And he is absolutely committed to India's scholarly tradition and has a very open mind. And which brings me to today's speaker, Professor Krishna AchutaRao. And as you can see, he is the professor and head of the Center of Atmospheric Sciences in the Indian Institute of Technology in Delhi. And before that, he worked at the Lawrence Livermore National Laboratory in California. His research is focused on using climate models to understand how Earth's climate is affected by natural as well as human factors and how it will impact natural and human systems. And his current interests include understanding extreme weather events, changing risk of extreme events under a warming climate, and adaptation to climate change. He has been associated with the Intergovernmental Panel on Climate Change, IPCC, since 2001, and was a lead author on the recently released 6th assessment report contribution from the first working group. He has served on numerous national and international scientific panels. And we're very grateful to Professor AchutaRao for speaking with us today about a subject that not many of us can claim to have a deep or even a passing understanding. So we're really, really grateful. Thank you. Krishna, can I pass it on to you?
Thank you, Aditya. And good evening, everybody. I'm going to start by sharing my screen, and perhaps you can let me know that it's visible and I'm audible.
It's visible and you're audible.
Thank you. So as Aditya has already mentioned, I'll be speaking on climate change. What the topic I've chosen is myths and reality. I'm grateful for this opportunity from Devagitam Trust and Abhignana for the honor of speaking on this occasion of the 7th Narayan Dutt Memorial Lecture. Narayan Dutt, or Nani Mama as I used to call him, or still refer to him, is as has been introduced, a journalist and scholar with wide-ranging interests. But to me, he embodies what I think as the epitome of rational thinking. He did not suffer hyperbole on anything. He would not hesitate to correct you with for those of you who understand Kannada, he would say Hagalla and go on into telling you what is the right or the correct way of interpreting something. Which is the reason why I've chosen the topic today on trying to separate the myths from reality. It's my small token to Nani Mama. I also want to acknowledge some discussions I've had with Rahul Ram, one of our cousins, Mila Mitra, and my colleague Ambud Sagar. Mila is my wife. So these discussions helped me kind of frame the way I'm going to present today's talk. I'll try not to be very high-level scientific presentation in the sense that I'll try to keep it at a level that hopefully the general public can follow. Okay, so I want to start with what we know about climate change and how long we've known it. So back in 1757, Joseph Black identified carbon dioxide in the atmosphere, and in the 1820s, Joseph Fourier understood that gases in the atmosphere might trap heat received from the sun. And by 1859, John Tyndall, working in the United Kingdom, was able to identify that water vapor, carbon dioxide, and other gases in the atmosphere could, as he put it, produce all of the mutations of climate which the researches of geologists reveal. A few years, almost simultaneously, Eunice Foote, an American woman who worked on this, also figured out that the changing proportion of carbon dioxide in the atmosphere would change its temperature. And by the end of the 19th century, Svante Arrhenius, a Swedish scientist, published a climate model demonstrating how the temperature on the Earth's surface responds to atmospheric carbon dioxide levels. So the reason I bring this up is that this is really old physics. We've known the basics of what sets climate for well over 150 years. So I'm not going to spend much more time on the science. And as John Oliver put it, you don't need people's opinions on a fact. For people who still think that climate change is not real, I refer you to John Oliver, because he put it rightly, certain things at some point become fact when there's nothing else to refute them. I will draw upon the statements and opinions of many of the world's leading philosophers of the day, and like John Oliver, even though he's a comedian, he speaks the truth. So this is a graph that shows how Earth's temperature has changed. You can see the years clicking by in the middle, and you can see how individual months of those years, temperature has changed, and you can see how as we come closer to the present day, these changes occur much more rapidly. I'll let it run through one more time if you haven't caught it. So early years, not much of a change, but once you get into the 1950s, things start really rapidly changing, and much more so in the last 3 decades or so. So the reason this is happening is all of that carbon dioxide and other greenhouse gases that we emit, which ends up trapping heat. And this is the equivalent of about 600,000 Hiroshima type nuclear bombs per day going off every day, 365 days a year. That's the amount of energy that we are adding to the atmosphere. And this has got consequences, but coming to our leading philosophers of the day, and I'm going to pick on Donald Trump quite a bit through this talk. The concept of global warming was created by and for the Chinese in order to make US manufacturing non-competitive. So this is dating back to 2012. So back when he thought it was all a hoax, an expensive hoax, because there's winter every once in a while and there's an ice storm, of course. And he goes on as recently as 2018 to say that there's a cooling and there's a heating. It used to not be climate change. It used to be global warming. That wasn't working too well because it was getting too cold all over the place. So again, if you notice, these are all statements made in the winter months of those years. So clearly, seasons don't change when you have more carbon dioxide. You still have a winter and a summer. But so this brings me to myth number one, which is first you called it global warming, now you call it climate change. Make up your mind which one is, right? And that there's something fundamentally different. But I'm going to say that they're not mutually exclusive. Global warming is the long-term trend of rising global temperature. And I've shown you the animated picture of how temperatures have changed. And this is just how the temperature of the Earth has increased. But climate change reflects not just that these greenhouse gases have resulted in warming, but that warming then affects our weather, which is what we experience on a daily basis, and which is what affects our lives. Climate by itself is something that you expect, but weather is what you get. So on a daily basis, you have weather that governs what happens, but that weather is changed as you change climate. And that climate is changing because we are warming. The myth number two is that climate has always been changing. We're not responsible. It's got to be the sun or something else. And here again, this is Donald Trump in 2018, where he changes tack. I'm not denying climate change, but it could very well go back. You know, we're talking about over millions of years. They say we had hurricanes that were far worse than what we just had with Hurricane Michael. So he's bringing up an important point, one that tells us that climate is not the steady thing. Let's examine what he is referring to. If we look at temperature in this red curve, this is what the temperature change has been since the late 19th century. You can see a steady increase, especially in recent decades. But if you look at what the sun's output is, and the sun is not a steady output, it flickers just like the voltage fluctuations that we get in our household electricity supply and bulbs dimming every now and then. You cannot look at these two and say that the sun caused all the changes. But if you go much further back in time, let's go back 3 million years, and these are values of carbon dioxide that existed going back 3 million years, and temperatures that existed going back that far ago in history. And these are data that are collected through what are called proxies, bubbles stored in ice that has existed for more than 3 million years. So you can see that over these millions of years, our carbon dioxide levels have decreased, temperature has decreased, but there's also a lot of variation. In fact, you can see these strong variations occurring in recent times. And we can focus in on perhaps the more recent times, the last 800,000 years. And if we look at what happened over the last 800,000 years, both the carbon dioxide and the temperature seem to be going lockstep. These changes occur because we sitting on Earth are kind of wobbling around the sun like a top, like a spinning top. And those wobbles create just enough changes in how we receive sunlight to cause these changes, and those changes end up causing temperature changes as well as fluctuations in the carbon dioxide. So this is all a time when there were hardly any human beings, but if you look at what happened in the most recent period, this last change from when we had ice ages, about 20,000 years ago, we had ice sheets covering much of North America and Europe. And this increase in both the temperature of about 5 degrees and of carbon dioxide took about 20,000 years. So 5 degrees over 20,000 years is a degree every 5,000 years or so, 4,000 years. But in the last 100 years, this is what we human beings have done to carbon dioxide. So let's zoom in on the most recent part, what the last 10,000 years. If you look at just the last 10,000 years, and this is just the temperature, it's smoothed, but we were coming out of the ice age. You can see the temperature has increased. And in the last 10,000 years, it's been remarkably steady, within like a half a degree, plus or minus, right? So these periods when it increased or decreased, when the temperature dropped, the Sahara dried out about 3 or 4 million years ago, 3.5 million years ago. There were droughts in Europe when it got a little cold. There was a little ice age in Europe when temperatures dipped by more than a half a degree. There was a volcanic eruption. So there are many things that happen that have implications here. So here's a period in Europe when it was unusually warm. And this period here is also significant because this is in this little blip that you see is where the Indus Valley civilization rose and then collapsed. Probably not collapsed, because what happened when the temperature changed here and went below, that period actually shifted patterns of rainfall. So what we knew as early urbanized Indus Valley locations marked in the yellow color, those early settlements from about 5,000 years ago ended up becoming more scattered, and there was a shift to a more eastward location, all because there was a small enough change in temperatures and it shifted rainfall patterns and you could no longer sustain those large urban sites. So it became more scattered. So it wasn't really a collapse, but over a period of about 1,000 years or so, the character of the civilizations changed. So the message here is that human settlements, human civilization, these are very sensitive to changes in climate. Enough to see these kinds of transitions, if you will. So when we talk of, or see a bumper sticker that says, save the earth, there's no planet B, I don't really see that as the problem of the earth. Earth as a planet is going to survive. What we're talking about is really save the humans, because our way of life is so intricately tied to the climate and the weather that we don't know how else to live. Our agriculture, our water sources, our livelihood, everything depends on the climate being the way it is. Myth number 3. What we're talking about with climate change is a 1 degree change, or perhaps another, so far, and perhaps another 0.5 degree or 1 degree change in the next 100 years. These are small changes, which is nothing compared to a place like Delhi, where within a day you experience a temperature range of about 10-15 degrees easily. So 1 degree doesn't feel like much. So this is what temperatures over, let's say, the Northern Hemisphere in this case. If I look at all the temperatures between 1951 and 1980, most years the temperatures around some sort of an average, normal, if you want to call it. But there are some years that are cold, marked in blue, and some that are extremely hot. Now, when I come to a more recent time, what happens is that that has changed. I'm ending up with fewer years that are cold, fewer normal years, more hot, and many more extremely hot years. So it's not just the average temperature that shifts. The average can only increase if your distribution of every day's or every year's temperature, 1 year being warmer than the next, when that happens is when you shift the climate. So what happens as you shift towards warmer and warmer temperatures is really what we need to look at. Hotter years typically have more fires. So these recent fires that have happened in Australia or Greece, these are images from the media, and these have been increasing in intensity and frequency across the globe, many parts of the world beginning to experience these. Warmer air can also hold a lot more water. So this is something that we've all experienced. A more humid season is when it's warmer. Drier climates, drier weather is usually associated with colder weather. So if you increase temperature by 1 degree centigrade, the atmosphere can hold 7% more water vapor. Right? So just that 7% increase means that our downpours get bigger. And this is something that's been happening of late. This is from last year, floods in Karnataka, in fact, all the way from Kerala up to parts of Maharashtra. There were these monsoon floods. Each time it rains, it seems to be a lot heavier than it used to be from our memories from even 20, 30 years ago. And these are actually documented increases in cyclones are getting more intense. And this is also because of the increased water vapor in the Earth's atmosphere. So when we look at these disasters, these are a consequence of just a 1 degree increase in our temperature. And if you increase another half a degree or 1 degree, these will all be further intensified. Myth number 4, plants need CO2, so they'll grow better. Climate change will be a good thing. In fact, plants indeed grow faster at higher carbon dioxide levels. These are pictures from an experiment people did by growing these same kind of tree at different carbon dioxide levels. This is normal ambient CO2. And if you increase that by 150 parts per million in this plant's environment, and 300 ppm in this, and 450 ppm, you can see that the ones with the higher CO2 levels have grown faster. In fact, this is what we call CO2 fertilization. So this indeed occurs. But this is not the whole story. There are other nutrients that limit growth. So if a plant grows better in higher CO2 levels, it also requires more nutrients. And if you have agriculture, you'll have to fertilize this even more. Plant defenses to pests and other things appear to go down as carbon dioxide levels go up. There is lowered tissue concentrations of nitrogen and protein, and there's just more starch, and this has implications for nutrition. And also there are certain kinds of plants. Plants have 2 different photosynthesis mechanisms. There's a C3 and a C4 mechanism. So C4 type plants, which include maize and sorghum, etc., they don't respond as much to higher CO2 levels. And increased temperatures can also damage photosynthetic apparatus, especially if you have a heat wave or something like that. And these things have been happening much more rapidly. So there have been studies showing how wheat production has been impacted by climate change. And you can see there are many regions where you have browns and red colors and yellow colors. These are all places where wheat production has actually declined. Of course, there are a few patches where wheat has increased in production, but these reddish patches are projected to increase in the future. So it's not just the amount of CO2, it's all the other things that can negate the increased growth from carbon dioxide. Of course, there's, especially being in India, this myth never dies. In fact, there's some truth to this myth that overpopulation is the problem. Overpopulation has implications for many things, including climate, but the current climate problem is not necessarily due to overpopulation. So here's another famous 21st century philosopher, Bolsonaro from Brazil. And he's not unique in thinking that family planning is required, but he and the leader of Hungary claimed that if you went to the toilet every alternate day, you could save the environment. So there are some really interesting viewpoints. So let's look at the population question. So this is a view of the world where countries, areas are proportional to their population. So the larger the population of the country, the larger the surface area. So you can see India is huge, China is huge, Australia is tiny, and North America, especially Canada, is tiny, and so on and so forth. So if you look at how much these countries have emitted and now scale the areas and show those, now you see that Africa is nearly disappeared. What remains is a little patch of South Africa, but almost all of the rest of the continent is gone. We shrink back to what looks like our normal Mercator projection size. The US and Europe are huge. So this is telling us that, although our population is high, our emissions have been low. And you can actually make out the shading. Shading is representing carbon dioxide emission per capita. So the redder the color, the higher the per capita emission. So it is hugely skewed towards populations that are richer. The richest 10% of the global population actually emits nearly 50% of all emissions. So this is lifestyle consumption emissions. So the poorest 50% of the global population is only releasing about 10% of the global CO2. So while population does matter, it is how the population lives that ends up mattering much more than how many they are. So this is an important thing to keep in mind as we are a developing country and we would like to be more affluent, and if we aspire to have all the lifestyle comforts of the richest 10%, then of course the emissions in the world are going to go up. And even within India, this sort of a spread of the richest among us emitting the largest is certainly true. Myth number 6, we are a developing country, we don't have the time or resources to worry about climate change. And this is an easy one to bust because many world financial economics experts have shown that whether we like it or not, we're already paying for it. All of the changes that have happened and the cost of development, all of those go up with climate change. So just to pick on the 10 most costly disasters of 2020, there are, of course, these large amounts that are a result of hurricanes in North America, Central America, the floods in China that caused a lot of damage, fires in the USA. But if you just look at 2 disasters that happened in our part of the world, so that's 10 billion for floods that occurred. And this is just monetary damage. There were more than 2,000 people that died. 13 billion is just from one cyclone in India and Bangladesh. 4.9 million people displaced. So that's 23 billion just within a few months of each other. And this is not counting all the disasters, which we don't yet know how to do very well. So that's 23 billion there, and just the sum total of all the foreign direct investment in India was about 71 billion. So if you add up all the other disasters, much of what we think is going to help us develop is wiped out. So this is a huge concern that not paying attention to climate change means that we will not be prepared for these kinds of disasters, and they will keep unfolding and displacing people, killing them, and leading to economic damage. And that's important if we have the threat of another half a degree or 1 degree warming that's going to make more of these disasters lethal. Myth number 7, technology will solve all of our problems. So this is an easy one for people in India who tend to be vocal. More technology, more engineering will solve everything. And this is true not just in India, but globally. And this is a note of caution from Mr. Trump. Noise of wind turbines causes cancer, but be that as it may, this is renewable energy as it has changed over the last 50 years or so, 56 years. You can see how hydropower was really the only game in town till very recently. And in the last couple of decades, you've had other renewables such as solar and wind now starting to really contribute a lot more to the growth of renewable energy in the world. So this is technology at its finest, where you can produce power from something that's constantly replenished, the sunlight or the winds, which is caused by energy from the sun. And so this is fantastic. But here's a cautionary tale. So if you go back the last 2 centuries, this is telling us what fraction of energy consumption is from different sources. So clearly, till the mid 1800s, where firewood was literally most of our energy source. It's in the 1850s or so that we started getting more and more coal use. And it's in the 20th century that oil, and late 20th century before natural gas became major suppliers. But if you look at as recently as 3 years ago, the share of all of the renewables is less than 10%. Now, all of this below, the gas and the oil and the coal, is all going to have to go. We are going to have to zero them out in order to meet our energy needs. So this is well over 80% of all the energy that we consume, not just the electricity, all energy. And this is a daunting task, especially because we emit things from agriculture, the fertilizer that we use, the fertilizer that we manufacture, the rice growing techniques that we have, they all produce greenhouse gases. Cement manufacturing is another industry where we really are going to have a hard time reducing emissions from all of these. So none of these is easy, and none of these is a purely technology fix, because a lot of this depends on how human beings behave, how well they adapt to new technology, and how receptive they are to all of that. There's a lot of social issues that go into how you can increase the uptake of these alternative technologies, and not always that the best technology wins. It's the most usable technology will have to be ushered in, but that takes a lot of effort. So this is not a daunting, this is not an easy task, and it is not the technology alone that's going to determine how we're going to get out of it. Myth number 8, which is actually, unfortunately, a rising thing, growing concern, especially with younger people. They think that the world will end in 2030. So, Steve Schneider was a famous climate scientist, and his words were, "Good for you and the end of the world are the 2 lowest probability outcomes." We've already seen this good for you part of it with the plants being fertilized by higher CO2 levels. But the end of the world is the other end of possibilities. And they're really the lowest probability outcomes. What we have is signs such as this in climate marches: you will die of old age, but we'll die of climate change. This is the young people. And then there's doomsday clocks counting down how many hours and days we have before. The truth is that more greenhouse gases we emit, the larger the global warming and more dramatic the change. We should stop CO2 emissions as soon as possible to limit this disruptive climate change. But there is no cliff that we fall off when we reach 1.5 degrees or 2 degrees warmer than our pre-industrial times. These are targets that are set to limit the changes, so that these are levels of temperature or changes that we actually can adjust to. Beyond this, the changes get harder and harder to adapt to and live with. That is a concern, but this is not that at 1.5 degrees, suddenly the world is going to end. So this is something that more and more young people seem to have taken into their minds, that they're all going to die and that the world is going to end. And this is doomism that really there is no basis for. But we have to understand that we as adults, most of us at least here with children or grandchildren, are here for a little while, and the planet is going to be our children's or our grandchildren's. We, as this Native American proverb brilliantly puts it, we borrow it. So what we do today really is not necessarily for us, but for the future generations. And this is something that we can do and take action to limit climate change. There are many personal lifestyle choices that you can find many places where this advice is given. A chart like this, for example, talks about low impact, moderate impact, and high impact, and the highest impact being have fewer children. So these are all fine to put on a chart, a nice, pretty looking chart. But many of these things, like, upgrading to LED bulbs or hanging clothes to dry, and, eat a plant-based diet. So these are all things that we here in India are stuck with. We've done it forever and we'll probably continue to do it. But these are personal lifestyle choices and they are not adequate. So this switch to lower carbon futures is not going to be dictated by whether I switch off a light bulb and save, an hour's worth of time. These are good to do. These are healthy things to do. We don't need to waste energy or money or unnecessarily add to carbon dioxide, but fundamental changes need to happen in our energy systems. What does the government pay attention to? What future development choices we're going to make? These are higher level decisions that have a much bigger impact on our climate than whether I forgot to turn off a light bulb. So while personal lifestyle choices are good, they are morally defensible, they are not adequate. I'm going to close with two important statements from my friend Trump. It appears that he's finally changed his mind, or at least as of 2020, that he believes in the environment, that he believes in a clean water, clean air, and everything. But this from a man who led the most powerful country, the biggest emitter of greenhouse gases for over history, is in some ways indicative of the kind of leadership the world has seen in terms of this problem. He's an extreme case, but let's not kid ourselves. There's a large part of the world that does not think climate needs to be addressed, or are doing everything to continue to hold on to unsustainable lifestyles. Those should be the real targets, and that's how we're going to address climate change. Thank you. And I'll stop here and take any questions you may have.
Thank you very much, sir. Very well explained the analysis.
Thank you, Krishna. Thank you for a fantastic talk. And there are some questions coming in, and shall I just read them to you, and would you answer them as you see fit?
Sure.
One from Sridhar Sarthi, which is, there is talk that the Arctic ice cap could melt in the next 50 or 100 years. What is the consequence of such an event?
Yes, so the Arctic ice caps actually serve an important purpose in that they, by virtue of being this bright, shiny surface, snow and ice is really bright, it reflects a lot of the sunlight that it receives. So it actually helps keep the planet cool. Once that ice melts and goes away, that shiny thing is no longer reflecting back a lot of the sunlight, and that means that we end up absorbing more and more of the sunlight and get warmer even more. So that's one consequence. But what's already being seen is that changing where that ice exists, if you melt away all the ice and it becomes open ocean there, it can actually change a lot of the weather patterns. Already places in Europe are experiencing changes in weather patterns that they have linked to changes in the Arctic. And we are finding here in India is that a lot of our weather systems could also be affected by what happens in the extreme North Atlantic Ocean. So what happens in the Arctic doesn't stay in the Arctic like Las Vegas. It actually ends up affecting many parts of the world, and that's a cause of concern.
Thank you. And there's a question from Vasanthi Cullerton in Philadelphia, which is, and I think this is partly related to your last slide, which is, what actions then can individuals take to address this problem? So if those individual actions you've said are not going to be sufficient, what actions can individuals take?
I think the biggest action any individual can take, especially those of us living in democratic societies, are to be vocal and influence your decision makers. It is, it's not something that the market forces will take and solve for themselves, because the market doesn't recognize these externalities, as they call them, where some industry is just going to dump something into the atmosphere and there is no price to pay for the industry. It's so when it comes to a public good like our livable climate or reasonable weather, these are things that the public good has to be taken care of by governments. And if governments recognize that they are leading a population in the wrong direction, then they can take steps to fix. And that can only happen when we, the people, are able to influence our lawmakers and our decision makers. And that's a bigger bang for the buck, if you will, compared to reducing your own consumption. Because those huge structural changes on the kinds of development pathways you want your country to take will affect the climate much more.
Thank you. And for those of you who are sending in messages, for those of you who don't know, any questions that you have, please put them into the chat box and I can pass them on to Dr. Krishna AchutaRao. Question from Chintan Amrit. Regarding technology being a solution, what about carbon capture technology? A recent Nature article suggested that it could capture 99% of the carbon in the air.
Right. So carbon capture technology, for those who might not be familiar with it, is essentially sucking CO2 out of the air and putting it away somewhere. Right? You either capture it from the free air that you have, or more efficiently where you actually burn things, so you have higher concentrations of carbon dioxide that you can remove. And the solution of carbon capture and storage is to capture that and then put it underground where you used to have the oil or natural gas, and lock it up there so that it stays for forever, essentially. So while this is one of the things that is considered as a technology fix, so far there hasn't been a demonstrable pilot project that has worked on this. There's no proof that this can be done at scale. Perhaps I can take it out of one thermal power plant and put it underground and it'll stay there. Perhaps I can do that. And that level of scaling they've seen, but not at the level where you can capture 40 billion tons of CO2 every year. That's how much we emit. To take all of that out every year and put it away somewhere is an enormous task, and that level of scaling has not been demonstrated. And it looks attractive, but at the moment it's just a concept and it's not been proven. And I have grave doubts that this can be done. It's also hard to keep things underneath when you're essentially going to pump huge amounts of CO2 and pray that it stays underneath. It sounds very hokey to me.
Okay, thank you. And one more question here, which was, for the next 20 or 30 years, should agriculture or horticulture be focused on developing drought or flood tolerance?
So I'm by no means an expert in agriculture, but I think this is going to depend on where you are, what your hazards are. There are some regions that are going to be more prone to floods. There are some regions that are going to be more prone to drought. So depending on where you are, the kinds of tolerance of varieties that you're going to have to develop, or the practices you adapt, these are going to change. Having said that, unless this is if this is about maintaining security of your production of food, whether it's horticulture or agriculture, it's not going to address any fundamental changes in emissions. It's going to ensure probably that you don't lose productivity. But there are farming practices that are being talked about that can actually help reduce the dependence on external inputs of fertilizers, which contribute to emissions. There are ways in which farming practices that include putting in specific carbon, increasing the carbon content in your soil, which is better for your crops in any case, So those practices are being looked at as not only maintaining your yield and productivity, but also helping reduce the amount of emissions in your from your agriculture or horticulture.
Thank you. We're nearly out of time, but I wonder if you have time for two more questions. The first is a follow-up question from Sridhar Sarathi. If we were to influence our lawmakers and decision makers, what are the 2 to 3 most important actions that we can ask them to take? This is related to the previous question, but as you can see, it's a follow-up. What would we want our politicians to be doing?
Right. So first thing is that, we are a developing country, and perhaps 50 to 60% of our infrastructure is yet to be built if we are to call ourselves a more developed country. So we are in a situation where we need to do things that do not repeat the mistakes or mistakes in hindsight, if you will, that the Western world has done. Now, we have an example. In the past, we all wanted a telephone landline. It was the premium commodity in India, and then suddenly nobody wants them anymore. Everybody is just leapfrogged into mobile technology. So there are things that one can, pathways in development that one can take where you're not necessarily following that same path. And one of the pathways in the development of much of the world has been that it is a carbon intensive development. Are there ways in which our energy needs and our standards of development can be met without burning that much fossil fuel? I think there are. There's certainly, that is one thing that we need. And I think, to be frank, the Indian government is looking at ramping up, renewables, but perhaps it needs to be done at a much higher level. A second one is also in terms when I refer to infrastructure, there are ways in which we need to make what's coming with climate change, whatever we and the rest of the world does, there is still some climate change that's upon us. Another half a degree to a degree warming is going to happen, and which means that there are things that are going to get worse. And when it gets worse, we don't want to have built our towns and roads and railways and all of those things where those impacts are going to be worse. You talk, to this day, there are these, big projects of being talked about. There's going to be this major railway in Kerala that's going to go on the Western Ghats. And the thing is, these are sensitive areas which are prone to landslides and things like that, which get worse when it rains a lot. So you're asking for trouble to try and build these railways. And I know there's been some attempts at building those kinds of, or talk of building those kinds of railways, even in Coorg and whatnot. So just like the Konkan Railway. So these are infrastructure projects which are supposed to be done. But if you're not going to account for what's coming in the next 20, 30, 40 years, then these are projects that are A, going to cost a lot, and B, at the end of the day, be completely worthless because they all got washed away by the consequences of climate change. So I think the citizens of this country need to pay attention to these choices being made in terms of where are we accounting for climate change. Just like today we look at, every decision is sort of influenced by what is happening with the pandemic. Am I going to be able to travel here, do this, do that, because there's a next wave coming? So there's a little bit of keeping COVID in mind that in all of your actions. Similarly, in all the decisions that the government makes, they have to take climate change into account in order to make those decisions. And this is where I think citizens need to be wary and be informed enough to take some, bring some voices into the debate.
Thank you very much. It sounds like the more we talk, the more questions are coming up. So I think if with your permission, can I ask 2 more quick questions? Or how
Sure, I have all the time.
Oh, excellent. Great. So Vimla Rajgopal from the Philadelphia family asks, how large an impact has the warming climate had on the Himalayas?
Yes, very, very important
Philadelphia, I'm saying
question.
Himalayas. Yeah.
Yes. So, I mean, the warming of the atmosphere has resulted in much of our land, ice and snow regions shrinking. And this is true all the way from the Arctic to the Alps, to the Rockies, to the Himalayas. Every one of these regions which had snow and ice is losing that. And for India, this is a very crucial thing because, as you know, there's all the way from the Hindu Kush mountains to the eastern Himalayas in Arunachal Pradesh and Sikkim. These are heavily dependent, or these regions are heavily dependent on the monsoons and other westerly disturbances bringing snow and rain. So warming has not only changed the mix of whether it's snow, solid precipitation, or rain, which is liquid. And if it's liquid, it just runs off. If it's solid snow, it stays there. And if it continues to be cool, then it'll accumulate and be ice, which can melt in certain seasons, but will sustain itself. In the Himalayas, there have been enormous changes in glaciers. We don't have all of our glaciers and snow-covered regions fully mapped, but the ones that are well mapped and observed, like Chota-Shigri Glacier, for example, they have been losing mass and of ice quite rapidly. There's one region, of course, called the Karakoram, where there's a little bit of an anomaly. In the Karakoram hills, there's ice and snow seem to be doing fine. They are stable for now, but we don't know how long that will continue. But melting glaciers in the Himalayas is a huge question. And there's not just the melting of glaciers, it's also melting permafrost, which is just the frozen soil part of it. And when that happens, when the soil in the mountains is loosened, it can lead to landslides and other hazards which have their own set of consequences. So it's not a pretty sight for those issues there.
One more question, which I'm afraid I can't understand, so I'm just going to read it. I'm sure you will, which is, if you could drive a specific IPCC/CMIP experiment, that is for CMIP 7, what would it be and what output would be necessary? This is from Jay Nilo.
Jay Nilo is an old colleague of mine and runs one of the he's a program manager at the Department of Energy in the US. So he's getting free feedback on his program. It's what it looks like. But I'm happy to answer this. So I think there's it goes back to one of the things I was talking about is we should be basing a lot of our development decisions on what is coming down in our future, how climate is going to change and what kinds of impact it's going to make. At the moment, these experiments, modeling experiments that help us understand the future climate change that we are going to see have very little relevance at the more regional, local levels. We have to do lots of things in order to, infer the changes that could happen, let's say, in a state like Karnataka or a smaller one like Delhi. So I think a primary focus of the modeling experiments that we do needs to become less centric on what to do globally about climate change. I think that question's been more or less answered and beaten to death. But we need information on what can happen regionally, locally, because there the situation is much more complicated. So we need more information on, to use jargon, local feedbacks that occur, local scale drivers of climate, which can be very different from the global scales. So that's for Jay, that should be sufficient information, but
Thank you.
thank you.
Thank you, Krishna. And the next question is from Miti Desai. Is there any way indigenous knowledge systems can contribute to the problem, or presumably the solution too?
Solutions to the problem. Yeah. I think this is really important because this goes into what we call adaptation to climate change, right? So I'm working, for example, with a group of researchers that have studied the Kutch region in Gujarat and the Sundarbans, for example. These are very different regions in terms of their climate and what happens with climate change. One is a dry, arid region, the Kutch, and the other one's a wet region, or almost at below sea level and disappearing rapidly. So the question is, each of these regions has experienced the kinds of variations that gave them severe droughts or severe episodes of flooding in the Sundarbans, for example. So the people there have certain ways of resilience built into their lives and livelihoods. So they do certain things, certain practices that carry them through ups and downs that climate produces. Every few years you have, ups and downs. So these variations are things that they are actually the best people, rather than somebody sitting in an office in Delhi, is IIT, telling them how they should adapt to climate change. So it's for us to figure out, before we put out these, one size fits all kind of advice on what to do when climate change hits. It's upon us to learn what they did, how they built agricultural resilience or resilience to deal with water shortages and variations that occur. How do they manage it? What kinds of cropping choices they have? Or if they're pastoralists, what do they do? So that information is actually crucial to what we can learn about how to run government programs, rather than, for example, what kinds of subsidies need to be given. Are you going to subsidize everybody's, sugarcane growing madness everywhere? Or are you going to tell them, look, these are drought resistant crops and these are the kinds of things that you've been doing for, centuries and shouldn't have to run after the cash crop money, right? So there are things that we, as the if you will, intelligentsia or the government, the bureaucracies, we need to understand that our solutions, our set of policy choices are all informed by local and indigenous practices, rather than some textbook diktat that came from who knows where.
Thank you. Ganesh asks, people or companies buy carbon offsets. Are carbon offsets legitimately helping the environment?
Okay, great question. And this is actually a debate that, and the consensus, I don't know if it exists, but the growing impression is that some of these do not work. So if I hop on buy a if I buy an air ticket flying to Bangalore or London or wherever it might be, if I buy offsets and somebody plants 3 trees, is that tree actually taking up the amount of carbon dioxide that my share of it from that flight was? And these are very hard to actually measure and authenticate. So if somebody says, I'm planting 3 trees, we don't know whether the 3 trees survived at the end of the day, because all these afforestation or reforestation measures really they don't always survive. And if those trees did survive, whether they took up the advertised amount is highly suspect, because we don't have very accurate methods of estimating how much the tree grew in that particular year, and therefore how much did it actually take up. These are things that are highly variable and highly individualized to the kinds of trees, the kinds of ecosystems they grow in, and what happened in that particular year. So for somebody to say, it's an offset, I think most of these offsets as they currently exist are, I'll plant a tree somewhere, unless they come up with, here's the box I've stored that much carbon dioxide, and here's where I'm burying that box. Unless that kind of a solution comes, it's always going to be suspect.
Thank you. I think last 2 questions, I promise. They just grow.
Sure.
R. Srinivas asks, does moving away from diesel technology to electric technology or alternative technologies really help to reduce the CO2, considering the amount of CO2 that would be emitted during the manufacture of these alternative technologies?
Sure, great question. Yes, it does make a difference, because especially if it's a diesel engine, for whether it's for automobiles or for other kinds of vehicles, ships, etc., diesel is highly polluting. It not just puts out carbon dioxide, but it also puts out black soot particles, which are yet another source of warming of the planet. So when one talks about manufacture, let's say you take 2 cars, one is an electric car and the other one's a diesel car. These typically have similar lifetimes. Perhaps the EV electric vehicles have a longer lifetime. So the energy and the resources that you spend building a diesel vehicle is probably a little more than what you spend in building the electric vehicle. Of course, the electric vehicle, the assumption is that you're going to charge those batteries from something that is clean. Now, currently in India, more than 70% of our power generation is from coal. So clearly, that's not a great alternative to burning the diesel. But as you increase the proportion of renewable power that goes into you charging your EV, the differential between how much you would have emitted if you owned a diesel car versus how much you emit when you have an electric vehicle is just going to, it's a no contest when you start adding more and more renewable fraction to your electricity generation. So it's a clear win. And for a while, people were skeptical. 20 years, I wouldn't say 20, 10, 15 years ago, there was actual concern that this might not be helpful, but all calculations in more recent years indicate that it's a no contest. EVs are the way to go. They have other problems, other issues, but not in terms of carbon emissions.
Thank you. The next question is from, I think, Mr. Kashinath or Dr. Kashinath, I'm not sure. It says outstanding talk, and a lot of people are saying outstanding talk, Krishna. Thank you. Would you please comment on the contribution of methane to climate change?
Yes. Carbon dioxide is something that I've mentioned more often, more frequently than methane. Perhaps I should also mention nitrous oxide, which is one of the things that agriculture produces, but methane is also produced somewhat in the rice paddies, where you have that standing water that ends up preventing aerobic respiration. So when you have anaerobic conditions, you end up producing methane. Methane also released from coal mining, natural gas, all of those, all the industries there. Methane is a much more potent and powerful greenhouse gas compared to carbon dioxide. But it doesn't survive in the atmosphere very long. It gets taken out of the atmosphere and oxidized and removed through various chemical reactions. It lasts only about 12 years or so. But during the time that it is there, it is much more potent. Now, if you have some methane that you release, in the next 50 to 100 years, there's no trace of it. But if you release some carbon dioxide, it stays there for thousands of years. There's the lifetime of the carbon dioxide in the atmosphere is so much more that methane's overall contribution to the warming pales in the long term. In the short term, yes, it does have an effect and it does make a difference. So methane sources should be reduced, but the big dog really is carbon dioxide because it doesn't get out of the atmosphere for many thousands of years. And during that time, it has this lingering, continuous impact on our climate. And so the ultimate solution is that all forms of carbon, methane or CO2, all have to go. But methane is short-lived and CO2 is very long-lived in the atmosphere.
Thank you. And positively, the last question, looking to the future from Vasanthi Cullerton. Can you address the impact of cryptocurrencies on the climate?
Wait, okay. So it's not the cryptocurrency itself. It's how cryptocurrency is, to use the word, mined. So there's some hokey process by which cryptocurrencies are generated and mined all the time, and it involves doing some silly calculations on the computer all the time. And so what this has resulted in is that many companies now have computers running 24/7, large computer servers with the ability to make all these calculations, and these take energy, and they are sucking up power that is not necessarily produced cleanly. They're using up whatever energy they can in the hope of making their cryptocurrency millions. So this has actually skewed a lot of energy production and emissions scenarios, in that the growth of cryptocurrency has actually not, if it's the kinds of servers that the Googles and the Facebooks of the earth have to serve up, our social media content, these companies may pay attention to, their carbon footprint and how green they are and whether they're getting green sources of energy. But the cryptocurrency is like the Wild West, where none of these companies actually probably think about whether they're getting clean sources of energy. And so it's actually resulted in a little bit of a skewed emissions from cryptocurrency servers. So this is as far as I know. I don't know whether the currency itself has implications for emissions and climate change. It's how it is mined.
Thank you very much. I think it's a testament to your talk that we've gone over for so long, and I think most of it has been questions and answers. Just looking through the chat box, as you should, there are lots of very positive comments. Outstanding talk, educative talk, eye-opening, and really very well received talk. I think there were lots of people who said they've really, really enjoyed your talk and how approachable your subject has been. Thank you very much.
Thank you.
On behalf of everyone, thank you very much for agreeing to talk to us and for all the time you've spent on the questions and answers. And also an apology to those of you who tried to go through the YouTube link first. I apologize, there was a glitch and our YouTube streaming did not happen. We have, however, recorded this and we will upload this to YouTube with Professor AchutaRao's consent.
Thank you. I'm happy for it to be uploaded, and thank you all for the wonderful questions and your kind comments on finding this accessible. I took this invitation with a little bit of trepidation because my audience has typically been scientists or aspiring scientists, and I've done a talk or two to a more general public, but this was by far the most daring I've been. So thank you for bearing with me, and thank you.
And on behalf of Devagitam and Abhignana Trust, thank you very much. And thank you to all of you who've joined and for your interaction. Thank you. Have a good evening.
Thank you.